In the last video, we talked about types of data and different classifications of data. And this video, I would like to talk about collecting data. So I want to talk about various different sampling methods, which ones are better in terms of their randomness and which ones aren't as random. And so before we get started on that, I just want to review our definition, or my definition of statistics. The way I think about statistics is the collection, organization, analysis, interpretation, and presentation of data. Now, one of the main topics, at least towards the beginning of my last video, was a working knowledge of statistics allows you to not be influenced or manipulated as easily, or to make intelligent decisions. Well, on the flip side of that, a working knowledge of statistics can allow you to manipulate other people. So this manipulation could be done at any stage in this definition: collecting, organizing, analyzing, interpreting, and presenting the data. So just for example, so in this slideshow, I want to talk about the collection of data. So let's say I ask, just picture yourself in a classroom, 25 students or so, and I'm standing at the front of the room, and I ask you a very simple question. I want to collect some data. It's a yes/no question. Raise your hands if your answer is yes. And if I ask the class, who here supports increased funding for U.S. military efforts in the Middle East? More money for military in the Middle East. Raise your hand if it's a yes. Do you support it? Don't raise your hand if it's a no. All right. That's a very manipulative way to collect data. So when you think about it, I didn't tell you what the increased funding was going to be for. Now, most people have a more or less a well-defined opinion of whether or not they support the U.S. Military being so prevalent in the Middle East. Okay, so will you support this, funding bill for increased funding? Yes or no? What's your vote? Well, the way I phrase it, it sort of sounds like if you say yes, you're in support of the military being there. But what if that military funding, which I didn't tell you what it was for, what if that military funding was to close up shop and transport troops back home? Well, then a lot of the yes results would have maybe been no's, and some of those no's might have been yeses. Of just the way I phrased the question, what information I chose to include or not include, just in collecting the data, the way I asked the question, I'm influencing you, whether or not you say yes or whether or not you say no. And so there's so much opportunity in this whole spectrum. There's so much opportunity for manipulation. Now, I said also that there's a very thin line between manipulation and lying. So when you think about the whole advertising industry, it's all manipulation. You're presented with advertisements, and those advertisements are meant to persuade you to do something, persuade you to buy that particular product instead of another company's product. It's all manipulation. And the way the data is presented has ramifications on what you believe, what you think about a certain product. All right, so if a company puts out a manipulating ad, that's legally okay. Maybe not ethically, but legally it's fine. If they actually outright lie, they could be fined tens or hundreds of millions of dollars from whatever government agency is overseeing that particular facet of economics. Okay, so let's move on with the notes. We're talking about the collection of data. Now, I say at each stage must be performed properly or your results will not be valid. So we want to always think about collecting data in the proper way. So we choose a target population. So remember, let me use a different color here because there's already red. So you choose a target population. You want to know something, you want to characterize that population. So what you want is a value for the population parameter. Which we almost never are able to determine because populations are usually very, very large. So what we do is we collect a sample and we collect some data from that sample. And so from that sample data, we calculate our sample statistics and we use those sample statistics to estimate the population parameters. Now, for the entire process to be valid, our data must be collected in a way that is random. So if the data is not collected in an appropriate way, anything that follows the data collection is not valid. Anything you do with that improperly collected data does not give valid results. So of particular importance is the idea of when you collect a sample of data, that it is indeed a simple random sample. That's very important for statistics. So what we mean by this, and so we sort of already talked about this, the way we collect our sample, the structure of the experiments, and so on, has a lot of influences on the result. And so a sampling method is biased. So this is sort of the opposite of the idea of a simple random sample. So biased versus simple random. So a sampling method is biased if every member doesn't have an equal likelihood of being selected. There's different ways of selecting a sample. Sometimes one is more appropriate than another depending on the situation. But in general, what we want is for the sample to be representative of the population. That's important because we want the sample to represent the population because we want the sample statistics to represent the population parameters. Okay, so simple random sample. For a collection method to be called simple random, two things. One, any one member of the population has an equal chance of being selected as any other single member. And two, a sample of n subjects is selected in such a way that every sample of n subjects has an equal chance of being chosen. So there's no, like, let's say we're choosing 50 people for a survey. There's no group of 50 in the population that is more likely to be chosen than any other group of 50. So it applies to groups, it applies to individuals. I think one of the examples I gave in my last video was if I, for example, wanted to estimate the average number of parking tickets someone in Boston gets each year. I would just go out and I'd ask 50 or 100 or 500 people. I would just ask people, how many parking tickets have you gotten in the last year? And I would collect the data. Now, if I don't have a car, so I take the subway, I take the T, I take the train into the city, I get off at the T stop, I stand outside the train station, and I ask people, how many tickets have you gotten this year? And then I get back on the T. I take the train to another station, get off, stand right outside the station, ask another 100 people or so, how many tickets have you gotten this year? I record that data. And then I do that a number of times throughout the city. That is not simple random, because people that don't take the train are much, much less likely to be part of my study than people who do. Or people with cars are less likely. Or people who don't live near a train station are less likely. So in this case, the people that are more likely to be part of my study are the people that take the train, as opposed to people that don't. So we want to avoid that. We want to avoid collecting data in such a way that makes some people more likely and some people less likely to be part of your study. And so when we eliminate those differences, our collection method is called simple random. A very common example of this, let's just keep it small. Let's say you have a population of, 100 people. You need to pick a sample of 10. For it to be truly simple random, one thing you could do is have each of the 100 people write their name on a piece of paper, put it in some container, and pick 10 of them out at random. You'd have to make sure each paper was the same size and each paper was folded in the same way. And then once you have 100 names on 100 pieces of paper in a container, you pick 10 at random. That is one way to achieve simple random. Now, names in a hat are not, is not always a viable method if your population is tens of thousands or hundreds of thousands or millions. But the name of each employee is written on a small slip of paper, and all slips are deposited in a box. Like this is, for small sample sizes. So a population consists of 845 employees of Nitra Industries. So you have, your population, the size of your population. Now, it's not introduced yet, but later on when we start looking at statistical formulas, our symbol that we're going to use for population size is capital N. So in this case, it's fine to use now. The population, capital N, is 845, and the sample is lowercase n. So those are going to be our symbols. Lowercase n means sample size, uppercase n means population size. So our sample is 52. So we need to select a sample of 52 employees. 52 names go in a box. 845 names go in a box. 52 come out. So that's a simple random sample. Another method, systematic sampling. Have a list of every object, usually people or whatever they are, every object in the population, ordered in some way, numerically, alphabetically, by age, by whatever it is, and you select every, in this case, every third, 1, 2, 3, 4, 5, 6, 7, 8. So you would pick, person number 9 next. So like in this case, every third person, every fifth person, every 10th person, whatever it is. So systematic sampling is only random if you don't start with person 1. Because if you start with person 1, then person 1 has a 100% chance of being chosen, and person 2 has a 0% chance. So you have to use some method for randomly picking where you're going to start. And once you have, I'm starting at position 3, maybe you roll a dice, or whatever it is. Pick a card, use a random number generator. Once you figure out who the first position is, then you pick every kth element in the population. And so if we're going back to the last example, if for these 845 employees, instead of putting names in a box, we would use systematic sampling. Well, we would have to determine, where we would start and how often we select an item off our list. So if we want 52 out of the 845, we got to divide, how many 52s are there in 845? So 845 divided by 52. And so that's your value for K. So if you pop 845 divided by 52 into a calculator, you get, so let me erase the K for now. You get 16.25, so K would be every 16th. You'll always round down. So it's like you have to figure out a random place to start. So somehow out of 845 positions, randomly pick one. Randomly pick one. That's your starting point. And so once you have your starting point, then you would take every 16th name after that first position. All right, another sampling method, stratified sampling. So this is usually done in combination with another type. So with stratified sampling, you subdivide the population into different subgroups, 2 or more different subgroups. Usually that share the same, some of the same characteristics. So for example, this being an election year, one thing, one common method of stratified sampling is you take all registered voters and then you divide them into groups. You have Democrats, you have Republicans, you have independents, okay, so excuse me. Stratified sampling means you subdivide the population into groups, 2 or more different groups, and then from each group you choose a sample. You randomly choose a sample for each group. Randomly choose a sample, and then for the independents, randomly choose a sample. So the stratification happens first. The stratification happens first, and then within each subgroup, then random sampling has to happen. All right, another sampling method. This is another example similar to what we just talked about with stratified sampling. Cluster sampling. So another sampling method is called cluster sampling. So the difference between stratified and cluster. With stratified sampling, the one we just talked about, with stratified sampling, that's too big. With stratified sampling, you choose some of the members of each and every group. So choose some of the members. Choose some of the members. I'm having trouble with members. Choose some of the members from every group. With cluster sampling, you're choosing some of the groups. So let's say these are precincts in a certain district. I mean, this could be zip codes in a state, or city, townships in a city, whatever they are. With cluster sampling, first you split the population into groups. Then choose some of the entire groups. So you would take every single person living in precinct 5. You would take every single person in precinct 16, and you would take every single person in precinct 28 if it's cluster sampling. If it was stratified sampling, if there's 32 precincts, you're taking a handful of people from each of the 32. Okay, so we have stratified, we have cluster, similar in some ways, a little bit different. Okay, another example, similar to what we just talked about. You pick three counties in the greater Chicago area. All right, so overview. We talked about simple random. This is usually done in conjunction with one of these other two. We talked about systematic, we talked about stratified, we talked about cluster. All right. And lastly, sampling error. Now, there's always, so we talked about, previously we talked about sample statistics. And we talked about population parameters. Now, usually the population is too big to work with, so we choose a smaller subgroup and we work with that sample. And what we want them to be equal. Now, they're usually almost never equal because you're leaving some information out. When you select a sample, you're leaving out members of the population. So there's data out there that you're not considering. So we want this. We want an equal sign here. We usually never get that. But what is attainable is an almost equal. So we want our sample statistics to be approximately equal to the population parameter. There's just almost guaranteed to be some difference. And that difference is called sampling error. And so we want that sampling error to be as small as possible. But there's almost always going to be a difference between the sample result, which we call a statistic, and the population result, which we call a parameter. And this is just error that occurs by chance. There's really nothing you can do about it. But that's our goal. Our goal is to collect data in such a way that our results are valid, meaning the data has to be collected in a simple random method. And two, we want to have enough data collected in a proper way so that our sample statistics are approximately equal or close to or representative of our population parameters. Okay, that does it for this set of notes. Next thing we're going to talk about is the organization of data. So we talked about, in the definition, step one. So let's go back to the definition. Should be here. Next one. Yeah. So this video is on the collection of data. Next one is on the organization of data. And so we're going to talk about frequency, distributions, and similar topics. Okay. That does it for this particular set of notes.